Okay, so now that we've addressed the part where now that we've addressed the main question, I have this additional question for you, which is a very common question in fact. If, right, the coefficient of static friction is mu, then what angle does the block start slipping? So we have the previous setup where we have gravitational force, right, mg, you have normal contact force, and you have friction at an angle, and the slope is the angle of theta, right? And when you derived previously that n is equals to mg cosine theta, f is equals to mg sine theta, and hence we could answer the question. Now my further question is, of course, in real life, we know that if we tilt the slopes steeper and steeper, at some point in time, right, friction is gonna be unable to hold the block up, and the block is gonna start sliding. So my question now is, what is the angle theta max at which the moment, right, the friction starts to lose out and the block starts slipping. And the key idea is that to note that friction, right, is equals to mg sine theta, provided it can handle it, right? If we increase theta, sine theta increases and friction increases, but remember that friction has a cap. Friction is always capped at mu n, right? Friction is always bounded by mu n, whichever direction is in, right? In this case, the direction is upwards, so it's going to increase in length. It's going to increase in length until, right, mu n, and that's the moment at which it's going to give up, right? And it's going to be kept there. It's going to be it's going to say, I'm trying my best, but that's the maximum value I can increase to. And at that moment, right, if we increase the angle even further, then, right, mg sine theta, the parallel component of the gravitational force, right, is going to eventually be bigger than F, and there'll be a net parallel component, right, net parallel force, and hence the object will start sliding. So basically, we have the answer right here, right? Since F is less than mu n, right, mg sine theta must be less than or equals to mu, and n is mg cosine theta. And if we cancel it out, right, we see that sine theta must be less than or equals to mu cosine theta. So that gives us tangent of theta less than or equals to mu, and hence the angle at which the object starts sliding, right, is the maximum possible angle, is the angle where tangent of theta max, right, is equals to mu. And another way to see this is that if we plot these two functions over here, right, we know that n cosine theta looks like that. Sorry, n equals to mg cosine theta looks like that. So this n as a function of theta, and we know that f as a function of theta looks like that, right? Where the horizontal axis in this case is theta, right? And further, we know that if we scale up n to be mu n, right, then it looks something like that. So this is mu n of theta, right? So at this point, so this is the graphical perspective of what we did. So at this point, let's say at this point, okay, I'm going to use a green color because it's a green signifies it's okay. At this point, you see that friction is less than mu n, right? So friction is happy, it's okay. It says I can handle it. I can handle it. At this point, friction is less than mu n, right? Friction is less than mu n. So it says it's okay. But the moment, right, the moment we hit this point where the friction graph intersects mu n graph, right? This is the point, theta max, where the friction is like, okay, I cannot, this is maximum value. And the moment you try to increase it, friction is actually gonna stay at this value, right? So it's gonna be capped at this value. Friction is not going to increase further. Friction is actually going to be kept at this value. So the graph of friction actually really looks like that. Graph of friction actually really looks like that, right? When this theta max, and we know that the relation, right, of theta max is equals to arctangent, right, tangent, or rather tangent inverse of mu, right? So that is the answer. to the extra question. Tangent theta max is equals to mu. And this is a common result. Something notable is we see that the angle at which it starts slipping is only a function of the coefficient of friction. Right? The angle at which it starts slipping is independent of mass. Whether it's a 100 kg object or a 1 kg object, right? The angle at which it starts slipping is always theta max, such that tangent theta max is equal to mu. There's no mention of mass in this formula. And that is slightly unintuitive, in my opinion. But that's what the math says, and so we got to build our intuition around the math. Alright, so that's for the extra component of this question. Let's move on to the next question.